square root of x, so those go away, minus the square root of x squared, that's just minus x, over, then you've got 9 minus x, don't even worry about this part right here, then you've got a 3 plus the square root of x, don't worry about multiplying this out, but if you notice, again, those cancel out, and you are left with, let me come down here, the limit as x goes to 9, 1 over 3 plus the square root of x is going to be equal to 1 over 6. So either way you go, it comes up with the same thing. You're going to end up with the same values. Let's knock this last one out really quickly, and then we'll kind of talk about this more in class later. So we've got the limit of 2 minus x as x goes to, or excuse me, the limit as x goes to 2 of 2 minus x over square root of x minus square root of 2. So again, two methods here that you could use. I'm not a fan of the factor method. I'm going to show it to you anyway. This is the factor method. You have the limit as x goes to 2. Reason I don't like the factor method is, again, the top, you have to treat that like it's a squared and b squared. So it's the square root of 2 plus the square root of x, square root of 2 minus the square root of x. It's the difference of two squares. You have to treat it as that, even though it isn't. We're kind of forcing it to become. All right, and then so we take this down here. On the bottom, we've got a positive square root of x and a negative 2. Now that's pretty close to what we have here, except that x is negative. So to cancel this one out with this minus sign, technically we have to take a negative out of the bottom. So we'll have a positive square root of 2 now and a negative square root of x. I took this negative out of the bottom here so that I could force these two to be the same. And what that does is allow me to write this as the limit as x goes to 2 of that negative sign out there, square root of 2 plus the square root of x, what was left from up here. So if you were to plug a 2 into here, right, you could also distribute that negative. What you'd end up with is a negative square root of 2 minus, well, technically plus another negative square root of 2 if you distribute this negative here and here. So you got your negative, plug your 2 from here into x. This is what you've got. That is negative 2 square root of 2. Again, I'm not a fan of the factoring method just because you have to force something to be something it's not. So the conjugate method, my personal fave, the limit as x approaches 2 minus x over square root of x minus square root of 2. So I'm going to multiply. I'm going to take this minus sign with my square roots and I'm going to change it to a positive. Square root of x plus square root of 2. Square root of x plus square root of 2. Top and bottom, multiply straight across. That's going to give me the limit as x goes to 2 of, down here on the bottom, you have the square root of x times the square root of x. So that's going to give you a x, basically. So you've got your, let me make sure I'm doing the right. Something doesn't feel quite right about that. Am I doing that right? Yeah, why not? Okay, so we got x, and then on the bottom you've got square root of 2 square root of x. So square root of 2x positive, square root of 2x negative, those go away, minus 2 on the bottom. On the top, what the heck, let's leave that the same, 2 minus x square root of x plus square root of 2. If I don't have to change it, I don't want to. Now these are pretty close, right? Pretty close. Pretty close. This is a negative x, this is a positive x. So I'm going to do what I did before, negative here, positive here. Change the sign of everything on the bottom, and now all of a sudden, da-da-da-da. And what do you know? The limit as x goes to 2 of a negative square root of x plus the square root of 2. Do the exact same thing we just did. Negative square root of 2 plus square root of 2, negative 2 square root of 2. Technically, this whole thing is your answer. I shouldn't have done that. Limit as x goes to 2 of f of x of your function, if, well, no, we can't do that. Never mind. Let's just circle this whole thing. There we go. Perfect. All right, that's that. And I'm going to go because they're lining up to do the thing again. Lord help us.